Hello. In this video I'm going to perform panel configuration model and panel VAR model. I have two variables such as money demand M3 and interest rate. I have 5 countries. The data is 14 years. Sorry, the data is 9 years. The observation 49 observation. First, before we start, we run the panel configuration test with M3 money demand as dependent variable and rate independent variable such as M3 constant and rate. And then out of the 3 method, I select cow method. If the rate with constant and M3, then M3 constant and rate, as you can see it here, if p value greater than 5%, then I use VAR model with 2 legs. Second, run panel configuration test with rate as dependent variable and M3 money supply independent variable such as rate, constant and M3. Then I run again cow method because I select one method out of a 3 method, Pedronic, cow and Fisher, so I select cow method. If p-value of this model greater than 5%, then I use VAR model with 2 legs. Third, after we find that p-value is greater than 5% of the second model or second panel configuration test, then I can now proceed to run VAR model. As first, we run it with M3 as dependent and rate as independent variable such as this. M3 constant, M3 lag 1, M3 lag 2, rate lag 1, rate lag 2. Of course, for VAR model always there is a lag. We have to use the lag. We have VAR model, then we have to test first for fixed effect model, as you can see it here, and then for random effect model, and then to see which model is most appropriate, then we have to use Houseman test, which he has the answer of this question. And here we have to state the Houseman hypothesis, such as you can see it here, null hypothesis, random effect model is appropriate, which means that if we accept null hypothesis and reject the alternative, it means that we have to run random effect model is appropriate, which means that, in other words, if we accept if we reject null hypothesis, we have to run fixed effect model. But in this case, null hypothesis, random effect, if we cannot reject null hypothesis, so we can run random effect model as appropriate, as you can. Then after this is the equation, we use it, M3 constant, M3 lag 1, M3 lag 2, and here rate lag 1 and rate lag 2. The same procedure as we mentioned earlier. If p-value less than 5%, use fixed effect model according to Houseman test. Run fixed effect model again because it is most appropriate. Let me just put the space here. Model again, and then we can run fixed effect model as a most appropriate model. Then I check the causality whether rate can cause M3 or not. using while test, which means that we have to use the null hypothesis C4 equals C5 equals 0, whether 0 or not. We have to test it. If it is 0, it means that the rate lag 1 and rate lag 2 jointly cannot cause M3 or money demand. It means there is no Cointegration. And then we have to run the Cointegration, which is the panel Cointegration with rate, different variable with rate as a dependent variable and M3 independent variable. Then we use the same procedure as you can see it here. We test for fixed effect and random effect. Then we have to get the answer which one is most appropriate. We have to use Hausman test with that. Now I'll go to eViews. I'll see the data here. You can see it, M3 and interest rate, and the data 2000-2009, 5 countries, the number of observation 49, as I mentioned earlier. So I have to, this is M3 and this is rate. We have to open this data, as you can see it here. Then we have to run the first one, as I mentioned here. We have to run the panel Cointegration test when M3 is dependent variable and rate is independent. So how? I go to quick, group statistic, Johansen test, and this is the variable M3 and the rate. Press OK. Here you can see there is a 3 type of test: Pedronic, cow, and Fisher. Out of these 3, I select cow. But we can run Pedronic and we check with individual intercept. So press OK. You can see here all the probability, 11 probability greater than 5%. We have to confirm that using cow. I go to view, Cointegration test, panel Cointegration test. I select the second one, cow, with individual test. If the p-value greater than 5%, this means that we confirm that Pedronic is the same as cow, which is p-value greater than 5%. Leave everything as it is. As you can see here, we select the automatic selection, the skewers, information, criteria, but you can use any of these. Kika information, criteria, Hanan, modified and modified skewers, but in our case we use the SIC. Everything remain as it is. Then press OK. Here you can see that p-value ADF T statistic, then we can see p-value greater than 5%. When we find it more than 5%, it means that we have to run the VAR model. So how to run VAR model? I'll go to quick, estimate equation, construct the VAR model as M3 dependent variable, which is M3 constant, M3 lag 1, M3 lag 2, rate lag 1, rate lag 2. This is the VAR model with lag. Always when we run VAR model, we have to use the lag, and the lag is selected by the default in the eViews. So here we considered M3 dependent variable and rate independent variable with 2 lag. Now we have to test for fixed effect model first. Panel, I go to panel option, select fixed, leave everything as it is, press OK. This is the outcome of fixed effect model, and here we have to test. If it is the appropriate one, we have to test with while test whether this rate is caused the M3, which is the dependent variable, or not. Then I'll go and check test for random variable. This is the, here we can see the random variable. Also we have to test which one is the appropriate. We have to use while test in order to see which one, whether rate lag 1 and lag 2 cause the dependent variable. But we don't know which one is the most appropriate. Houseman test has the answer. How? I'll go to view, fixed random effect testing, and go down here to correlated random effect, Houseman test. Press enter. You can see here p-value, which is a cross-section random, chi-statistic 1.8, and probability or p-value 76.96. Data we have, and we see the hypothesis for Houseman here. If null hypothesis, random effect model is appropriate. What does it mean? It means that if we cannot reject null hypothesis, it means random effect model is appropriate. And here what we have, we cannot reject null hypothesis because p-value more than 5%, which means that the random effect model is the appropriate. Then we have to test the while test to see whether rate lag 1 and lag 2 has any effect or cause the in M3. In this case we have to run random effect model again after we find it is the most appropriate. I'll go to estimate, go to panel option, random effect, press OK, and this is the outcome for random effect which we have already. So now we have to test rate 1, lag 2, whether they have any cause on M3 or not. How? I have to go to view, coefficient diagnostic, while test, and here press what we have here. We have C1, C2, C3, C4, C5. So we have to test C4 and 5 as a null hypothesis to see whether there is any cause of to M3 or not. C4 equal C5 equals 0. This is, we call it the null hypothesis. If we accept the null hypothesis, which means that the C4 and C5 equal 0, or rate lag 1 and rate lag 2 equal 0, it means there is no cause, no effect. Press OK. Here you can see every statistic 6.4, which is greater than 5%, which means that we have to say C4 and C5, rate lag 1, rate lag 2 has no influence on the M3. The second one here, after we test the wild, we have to use the second model as we can see it here. We have to use the second, which is rate lag 1, lag 2 as rate as a dependent variable and M3 as independent variable. I'll go to review, just click remove this part, and then I'll go to quick group statistic, Johansson test. Here we have to change rate and then M3. We put rate as dependent variable and M3 as independent variable. Press OK. Then we have to select Patroni first, Patroni with individual intercept and the automatic selection. Press OK. You can see most of all the probability greater than 5%. And then we have to test for cow, which is cow method, to confirm. I go to view, Cointegration test, panel Cointegration, select the second method, which is cow, Angel-Granger based, leave everything as it is, press OK. You can see here probability is greater than 5%, which is 37.93%. Here, when we find p-value greater than 5%, then we can easily proceed to run VAR model, because we cannot use error correction model because p-value is greater than 5%. Then what to do now? I'll go to quick estimate equation, put the model, which is now rate as dependent variable, constant, rate, lag 1, rate, lag 2, and then M3, lag 1, M3, lag 2. Let's double check here. Rate, constant, rate, lag 1, rate, lag 2, M3, lag 1, M3, lag 2. Here we can see that we put rate as dependent variable, M3 as independent variable, and here we have to run fixed and random effect. I'll go to panel option, I put fixed effect, and then press OK. This is the model for fixed effect, and then I run for the random effect. This is the random effect, but now we have to see which one is most appropriate in the second panel equation data when rate is independent variable, as you can see it here, and M3 as independent. So I'll go to view, fixed random, Houseman. Here you can see Houseman more than 5%, so we cannot reject null hypothesis, and here random effect model is the most appropriate model. Then we can run this model again, random effect. This is the random effect model. Now we test for the while test to see whether M3 lag 1, M3 lag 2 cause the rate statistically significant or not. Then we have to go to view, coefficient diagnostic, while test, type the C4 equal C5 equal 0. This is the null hypothesis for the second Cointegration, panel Cointegration. So if we say we accept null hypothesis here, it means there is no causality, or there is the M3 has no effect or cannot cause the rate. So press OK, and you can see here more than 5%. We have to accept null hypothesis and reject the alternative hypothesis, and then we can say C4 and C5, which is rate M3 and M3 lag 1, M3 lag, okay, has no effect on the, sorry, and this is what we have to do with the panel VAR model. After we run the panel Cointegration model, then later we use the VAR model to test whether which one of the model we used of course two model, M3 as dependent variable, rate as independent, then we reverse it as rate as dependent and M3 as independent. Then we test it for fixed effect and random effect. We find the most appropriate, then we test the while test to see whether this variable lag 1 lag 2 for M3 or lag 1 lag 2 for rate is cause the M3 or cause the rate in the model. Thank you.